Okay, hello. This is Rani Ahmed with you, Super Linux. I'm the programmer of the app General Engineering, and in this video, I'm going to present you the software and tell you what's all about it. Now, the app is about consolidating all the general engineering formulas, mainly the hard to memorize ones, and put them for you in this app. I'm not looking for things like multiplying two numbers. I'm looking for things like beefy stuff, and put them in a form, and that's easy to follow. And this is how we start the app by clicking on the general engineering here. Okay, now this is the full version that I'm displaying. Okay, the paid version. Of course, there are disabled things in the free version, and I will highlight them. Now, this is the first thing that you'll face when you open up the application. Okay, now we've got a unit stable. Okay, and I will rotate the screen here, so you get a list of unit stable. Okay, definitions, abbreviations. Okay, unit prefixes, electrical units, what are they? Okay, like if you forgot for any reason. And rotating back the okay, and I have physical constants. I skipped the convert units for a reason, because they are similar. Okay, so I get relative density of various substances, and I have universal constants here. Okay, you might need them. Then I go back to normal. Now I have a conversion between units, so I can select, for example, here from Fahrenheit to Celsius, Fahrenheit to Celsius. So you have minus, if you type minus 40, of course you must get minus 40. And for example, I say foot to meter. Okay, if I have like 1 foot, it should give you around 1/3 of a meter almost. Okay, so and you have forward conversion and backward conversion. Okay, and it's a very long list, as you can see. Now, don't want to go through this too much, it's already clear. And notice that you can, in any form, you can email the result and SMS the result. This, you will see it in all parts of the application. So this is how it might look like. So it will ask me to send the results as an email. It will open up it should open up the email application on your mobile device, and ask you might have Skype, you might have Facebook, I don't know what, your Gmail email client. It will list them for you, and will ask you to whether to send by email or by SMS. Okay, I can even through SMS and SMS the result. Oh, I said just cancel there. If I said send, so messaging will show up. Okay, and Here's the email. If I send, okay, now this is because it's the emulator. It's not a true it's not on a true device. It's not on a real device. If it's on a real device, you of course, for sure, you will see a list of email applications that are installed on your phone, and it will ask you to use any of. Now, applied math for engineers. So I can see here the geometry and area and volume, and I can select any, okay, of these shapes. Simply I can just multiply, maybe like 5, then go here for 3 and get 15, of course. Okay, and what's the circumference, what's the area? You can go for the sphere, for example, and you say the radius is 1. Okay, so you get the complete number without any rounding. I just leave them up to you to round them the way you like. Okay, and here I have significant centroids. Okay, so you just select the centroid of your choice, and you want to see where it should be located. Okay, and here's an example of one. Okay, I put the radius as 1, circumference, for example 30 degrees. Calculate it, and it will show it to you. Okay, this is just the distance, so whatever your distance is, there's no unit, this is unitless. Okay, oh sorry, and then I can have second degree equation, third degree equation, fourth degree equation, fifth degree equation. I can solve for any. If I want, I can go for the second degree equation. I rotate the screen, and I can just go, for example, here 1, then 2, then 1. Okay, and then I solve it, and then I can email the results for my friends. And here, if I want to go for the third degree equation, of course it must go and give me a complex evaluation. Okay, complex results. And I've seen there's a reset form. So if I, for example, let me repeat it. You see it in so many parts of the application. So I have to reset the form for me. I solved it, and then I can reset it. Okay. So that's the app. Now let's go for the important stuff. We've got you can calculate for Ohm's law in different ways of the disk of the Ohm's law. Okay, you've got the four members in the Ohm's law: the power, the intensity, and the resistance, and the voltage. And you can select the way you want. What do you want to find? Okay, and how you want to find it. Okay, I got the result here. Now we've got here also the resultant sum of resistances or inductances or capacitances. Okay, capacitors. You have up to 10 capacitors, okay, because they are more than enough. And you can change here, and the picture will change here. That tells you that I'm working with capacitors now. Here I'm working with inductances, okay, and you can tell it whether it's in series or in parallel, okay. Cool. And of course it will give you the results. If I have like some parallel, I have 1, it must be something like half, okay. Now there are things that are way over my engineering knowledge. I'm not an engineer, but I've collected so many formulas and I read about them and I made them. Got here like something about the change in the resistance because in the coils of the or I mean the windings of the motor, okay, because of the heat that the motor would generate. And so you want to see what's the final resistance value after change in the heat. We have the voltage drop, okay, you can calculate the voltage drop, single phase, 3 phase, or and whether you have it a copper or aluminum, or according to the voltage that you have, okay. And also here the resistance value, the color codes, okay. You can select the different color codes and it will tell you the resistance. Here Wheatstone bridge, okay. Here I have filters of Chebyshev and Butterworth, okay. So I have a low pass filter, high pass filter, Butterworth and Chebyshev, LC filters of course, and I have equal component Butterworth low pass filter and high pass filter. I have a Z attenuator and a T attenuator calculations. I have something related to helix antennas. You've got something related to battery life consumption. You have here something related to BJT transistor bias and voltage calculator, and I've got here an inverting op amp resistor, and also here something related to Zener diode calculation and the radar range calculation. And also here I have something related to lux meter. Now this won't work if you don't have a phone or a tablet that does not have a light sensor, okay. So the application will still work with you, still can download the app, but this feature is not really required if you don't, and it will not run if your device doesn't have it, okay. And it will show you exactly in see, I don't have it here because this is an emulator. So you'll see a light meeting here, and below here you will have the value of the maximum meter size and the current meter size, okay, or meter level. So this is all about electricity. And about mechanical, now you can have now here things I can understand, I can tell you more about. This is about like resultant sum of two forces. I can, for example, like 10 here, 10 here, and the angle may be 90. Okay, so to show you the force the other force with the horizontal force, and there is the over currently, before I calculate, there's another force here which is the resultant force vector. Okay, currently it's still overlapping because I haven't done any calculations. When I do calculations, okay, the resultant force will go of course in the middle angle, which is 45, between the vertical force and the horizontal force, because I have 90 degrees here, so this is it. Okay. And if I have maybe something like minus 90, okay, anyway, you'll get always the angle. Now, next, I have here something that you can use it with your like with your physics students, to show on the G inside the M inside the weight equals M times G. Okay, the acceleration of the Earth. So you can use a GPS here, okay, and it will and also you can put the altitude also in meters. So according to the altitude, you can see how the gravity changes. For example, I put it manually, and you will see how it. If I'm, for example, on 100 meters, okay. So this is us on 100 meters away. Okay. Now, if I'm using a GPS, okay. Now I don't want to go through emulation stuff, but just understand, you'll get something similar to this. Okay, and of course the button will be hidden, and you can use from the GPS only the altitude, or you can use both altitude and latitude. Okay, so you see something giving you the altitude here, your current altitude, and your current latitude through your GPS. Now, as a notice, as I wrote in the description of the app, if you are worried about your coordinates or any security breach, you can simply just disable your GPS device. Okay. I'm turning it off. Now, back. I have here something related to rectangular beam deflection. Okay, you say the weight of the beam, the width of the beam, the height, the thickness, the force. Okay, and whether it's hollow, it's not hollow. Okay, hollow or solid, and steel or wood, or whatever of types here. Okay. Same thing for the round beam. Okay, and also here you have internal screw thread shear area and external screw thread shear area calculations. That's a preview. Okay, this is another preview here. Okay, and Also I have a cam with follower. Now here you have a like a piston. This is this is a roller, okay, that's running over this ecliptic curve, okay, and because it's more like an egg, the roller will jump up and down over the eclipse here. So and it will finally draw for you the cam shape, okay, which is this ecliptic form, but it will not really look like an eclipse. It's according to your coordinates and your data, okay. So you get the coordinates and the graph of the cam. Now here you have a shear force, okay. You can make a study of the shear force, okay. You type the formula of your shears and you get the description and everything about it, okay, and you can then email it. You have here the Cartesian fluid flow analysis, also same. You put your formula, something like the above, and you get the whole complete description, and you can send it by email. Here fluid drag force too, okay, different shapes, and you can tell whether the fluid type that the body is flowing in is an air or water, okay. And here I have 4 beams. You want to calculate the cross section, for different cross sections that you see over here. We've got the rectangular, the circular, ecliptic, and the H or I sections, the C or U sections, the T sections, horizontally set or vertically set T, L sections, and Z sections, and X sections, okay. Here it calculates for you the moment of inertia, section modulus, and the radius of gyration, okay. And here is an example, okay. So you type the radiuses, say here 1 and here 2, okay, and calculate it, okay, because this is separate. So that's all. You get a radius of gyration, moment of inertia, say for example here 2, reverse them, and you get a value, okay. And here's the other types here, okay. That's all. Now this is now a proposed thing, soon will come, okay. I'm currently working on it, which is beam stress and beam deflection, okay, according to the location of the load on the beam, whatever its cross section and its section modulus, okay. So those are not yet complete. I'm still working on them, but this is the final outcome that I've reached on, okay, until today, which is Monday, July 29th, 2013. So that's all about the app. Now the parts which are not available in the free version are the shear force, Cartesian fluid flow analysis, fluid drag force, the beam stress deflection calculation, and the beam's moment of inertia, section modulus, and radius of gyration. Okay, those you must have the paid version for only $2. Okay, all that is for only $2. Guess. Okay. And also the lux meter is included in the paid version. It's not included in the free version. Okay, so that's all. Thanks for watching, and I hope you like the app. Okay, don't forget to buy the paid version. And one thing I have to remind you, if you buy a paid version on a cheaper price, you'll always have the updates on the cheaper price, the last price that you paid, that you bought at. Okay, and thanks.